And now, yeah, we can see how it works. So how can we compute an SUV image practically using, again, MATLAB?
Okay. I think that everybody can see my screen.
Yes.
Yes. I don't know where to put. I don't see me anymore. Okay, so as Ariana showed you, I already opened my MATLAB software, and I'm just, I know that I put my patient here. I'm going to use this one, and I'm going to go into the files where I want to be. So there's all the data that were sent to me. So this represents the PET image, and each files is one slice of the image. So because it's a 3D image, when you send them in a DICOM format, DCM means DICOM format, then you've got all the image in the same folder, but one slice by slice. So what I'm going to do, I want to first show you what's inside this data. So if you type in this type of thing, so I choose one of the file, which is the first one, but you can choose any one, you will get the same kind of information. Files is, you have in the file, you have the data number, and you also have the DICOM information of the data. So here is the first one. And if you have a look here, you will see that you've got some, so I double click on it. You've got all the information that you need. You see here that this patient was done in 2020, the 1st of January. And you've got the acquisition time and plenty of information. And I will show you here how that.
Sorry,
yes?
if I can interrupt just to disclaimer. Of course, all the information here about the patient, that is David Bowie, are of course dummy coded, so this is fully anonymized. David Bowie was never here on in 2020. I think he was already dead, by the way. So this is David Bowie. The other patient is Victor Tsoi. They are both singers, both dead. So everything is anonymized. So we are complying to the privacy.
Yes, sure. And I also, I'm not sure that the acquisition was not the 1st of January.
No, it wasn't so.
Okay. It's just that I show that if they take real data, they will have some data. So here I opened my SPM as Ariana showed you. I will import the data. So I have to choose my DICOM file. Actually, you can use specifier or you can just double check on it. And then you select all the data. Here, I'm sorry, I have all data because I tried it yesterday. So all the DCM files are here. I do done. Push on the green arrow. Okay, so it has been done. And now I'm going to display that data. So just the one I've done, and here it is. So that was that David Bowie patient. Is a bit sick, and well, the head was not really well positioned, but okay. And as you can see here, you've got here the intensity. So every time I move my mouse, I have different intensity. And I will show you what are the units of this intensity. So if I go back to my MATLAB, I got my information, and the unit, if you type in here, it's called, so you have to use the name of the data you gave yourself. And then I will use it because I know it by heart. It's okay. So you see that this information is BQML. So BQML in the DICOM standard means that the image are the image unit are becquerel per milliliter. So it is written BQML, but it is becquerel per milliliter. You may have other information about that. You can have counts, or you can have, well, other things. And of course, if you are interested in what kind of value this variable can take, you need to go to a DICOM site. You just DICOM, you Google DICOM in your net, and you will have plenty of information about DICOM structure. So about that patient, what kind of other information can we have? To calculate my SUV, I will need the time of acquisition to, if you remind, to correct for the decay. So the time of acquisition is here, acquisition time. And so I will keep it into another variable. It will be easier later. I will call that the time of acquisition. So time of acquisition is 3 in the afternoon and 47 minutes and 51 seconds. So if I scroll down here a little bit, I also have the manufacturer, which is here a Philips system, but of course you can have something else. I've got the manufacturer model name. So for the ones, if you want to know it, it is in the DICOM. I've got information about patient. I have the weight of the patient here. It should be there anyway. So again, because I will need that one for the SUV, I will just put it in a variable again, and that I will call W. So that's the patient weight. And for the DICOM standard, the patient weight is given in kilo. So this patient weighed 74 kilo. What else? Some other information about your scanner, the position of the patient. So you know that the head was inside the scanner and the feet out. Other stuff that may be interesting or not. I need something else. I need the information about the radiopharmaceutical, which is here actually. In MATLAB, radiopharmaceuticals information are in a structure, so I just have to click on it twice and twice again. Okay, and here are the information on my radiopharmaceutical. I will need the time here. Radiopharmaceutical start time is the time where the activity was measured. I will need it for my calculation. And as I am a bit lazy, I will put it also in a variable, because in MATLAB, if you want to use variable, you need to type in all the things. So I will need to type in info.radiopharmaceutical information sequence .item1 again radiopharmaceutical start time. Every time I will need that information. So I put it in here and I put it in T0, so it's easier for me to manipulate it later on. And I also need the activity that was injected, radionuclide total dose here. So again, I will put it in a variable so I don't have to type in everything again. Here. This is the activity that was injected, that again in the DICOM standard it is expressed as becquerel. So if you want to have it in a mega becquerel, you have to multiply it by a million, divide it, sorry, by a million, and you see that you have 146 megabecquerel that have been injected in the patient. I also have here the radionuclide half-life. I told you that for FDG it was 110 minutes. With here you will see that it is nearly 110 minutes. So I will use that half-life in my calculation. Here the radionuclide half-life is given in seconds. So again, it is DICOM standard. All the half-life in the DICOM header are given in seconds. I will use it in minutes, so I transform it in minutes, and to get minutes from second, you just divide by 60. So, okay. if you remind, in my calculation of SUV, I need the delay between, I will put it here. So I need the delay between the time where I measure the activity that I injected and the time where the acquisition was done. So if I take back my data, so the acquisition was taken, sorry. So the acquisition was at 3:47. The activity was measured at 3 in the afternoon. So the delay is 46 minutes, and you've got 51 seconds more. So it's 46 minutes dot 85 if you want to be very precise, but you can use 46 minutes. And then I want to express my activity. The activity at the time of acquisition, it will be equal to this formula. So that's the formula I showed you in the last slides. This one, it's just the one here, and then I can calculate it. So this is the activity, and of course it is the activity in becquerel, because I used it in becquerel. If I divide this activity by 1,000,000, then you see that it's 109 megabecquerel. So it's been injected to the patient 146 megabecquerel, but at the time of injection, this activity is actually 109 megabecquerel. And to calculate the SUV, I will need a ponderation factor here. So I will take my image, which is in becquerel per milliliter that I already showed you, and then I will multiply it by this factor. So I will calculate this factor by multiplying the weight in grams, as you see. So I will multiply the weight here by 1,000 because the weight is given in kilos, so I need it in grams, and I will divide it by the activity here in becquerel. So this is my ponderation factor. I will copy it, so I just do a Control-C, Control-V magic on a Windows, and I will come back to my SPM. So this is my patient. Just use ImCalc here. My input data is that one, so the one I just make. The other one, the output, I will call it SUVs, David Bowie, or call it as you want. Okay. And then I have the expression here. My expression, I have to use my image. So if you only have one image, it's E1. And I will multiply by the parameter I just calculate before. I do a OK, click on my green arrow, and it's done. And then I will, here you see that you've got the intensity of in becquerel per milliliter because you import the data like that. But then I can display my SUV, I just calculated. And here you see that you've got the intensity, which is SUVs here, everywhere. And it's done. You can use that data to compare to your normal database and so on. Any question? Ariana, do you wanted me to explain some more things?
No. For me, it's perfect. So in the end, we have, in this case, an intensity in SUV that is about 5.6 there in the occipital lobe. Maybe.
Yes, yeah. Here it's 5/6. Here, of course, you have nothing, but there was nothing.
Wow.
Here you've got 9.7, which is not a lot because On some patient, I've seen 12 or 13. So this patient is probably sick.
Yes, it is. It was.
Definitely.
Yeah. So yeah, but the value, I mean, like the average global value of SUV in a normal person is about 7.78. At least we have in our healthy control. So yeah, you can see here that there clearly this is a patient. So, and we will talk about it more later. But yeah, the value is not so. I mean, of course, it's decreased. Yeah, are there any questions? All clear how it is done? Of course, it's quite complicated. It can be automatized. I mean,
yes, you will have to